Acetylene gas is used in welding and has other important commercial purposes. Use these data to answer the following questions about its combustion at 25 degrees Celsius. First, write a complete balanced chemical equation for the combustion. Assume that the only products are CO2 gas and water liquid. Calculate the standard enthalpy change for the combustion of acetylene. Part C, calculate the standard entropy change for the combustion of acetylene. D, determine the value of delta G naught. And E, if 1 mole of acetylene is burned and all the thermal energy is used to heat 6 kilograms of pure water, what will be the temperature change of the water? The specific heat of water is 4.18 joule inverse grams inverse Kelvin. Here's the equation. What we do is acetylene is a gas, so we put that on the left side. And when we have combustion, we need oxygen, and that's a gas. And on the right side, we were told we get CO2 as a gas and water as a liquid. So you write them down without coefficients, and then you do trial and error until you have the right number of carbons, hydrogen, and oxygens on both sides. Calculate the standard enthalpy change. Here's our balanced equation, and here's our formula for calculating delta H naught. We take the sum of the products minus the sum of the reactants, paying attention to their coefficients. So let's look down here. Here are the products. Where did the 4 come from? Here. That's carbon dioxide. This one here is going to be water. Our reactants, we put down the methane right here with the 2 times 227, and there's nothing for oxygen because it's a pure element. So we get minus 2599.6 kilojoules. However, this is the enthalpy change for 2 moles of acetylene. We want to find it for 1 mole, so we have to divide by 2 to get the standard enthalpy, and we get minus 1299.8 kilojoules per mole. Calculate the standard entropy change for this reaction. Start with our equation here, the balanced equation. And this looks very similar to the enthalpy, except instead of an H, we have an S. So let's go ahead. The products, 4, that would be CO2, and 2 for water. So we get the chart numbers right here. And then what's different about this, for entropy, elements do have an entropy, unlike enthalpy, where they have a number of 0. So we plug those numbers in, and we get a delta S naught of minus 432.2 joules per mole Kelvin. But that's the entropy change for 2 moles of acetylene. All right, that's the 2 right here. Find the standard entropy by dividing by 2, and we get minus 216.1 joules per mole Kelvin. Determine the value of delta G naught for the reaction. We use our Gibbs free energy equation, and we've now found everything we need. Here's delta H naught. Here's T delta S. We plug in the numbers, and we get delta G naught is minus 1,237. And remember, convert the entropy in kilojoules per mole Kelvin for your answer. If 1 mole of ethene is burned and all of the thermal energy is used to heat 6 kilograms of pure water, what will be the temperature change of the water? The specific heat of water is 4.18 joules per gram Kelvin. From the standard enthalpy of ethene, which is 227 kilojoules per mole, we find that burning 1 kilogram of it will release 227,000 joules of thermal energy. Use this equation to find out how much that will raise the temperature. So first we solve for delta T, then Q, which is our heat transfer, or the thermal energy that is moved, of 227,000 joules. Here's our mass, and here's our specific heat of water, and we get the delta T will be 9.05 Kelvin.